Okay, class, in this lesson you are going to learn to identify congruent right triangles. So let's go ahead and begin with the following theorem. This is called the hypotenuse leg or HL theorem, and this basically states that if the hypotenuse and one leg of a right triangle, so let's take a look at this triangle, LMN. So if the hypotenuse, right, the hypotenuse is the side opposite the right angle. So if the hypotenuse and the leg, so one of the legs of this triangle, if both of those are congruent to the hypotenuse and leg of another triangle, so the hypotenuse here are congruent and the legs here are congruent, then we know that both of these triangles are congruent. Okay, so that essentially is the hypotenuse leg theorem. And the easiest way to remember is actually in the name itself, because we have the word hypotenuse and the leg. So if both the hypotenuse and the leg of a right triangle, not just any triangle, but a right 90-degree triangle, okay, if we have those scenarios, hypotenuse and the leg being congruent to the hypotenuse and the leg of another right triangle, then we know that both of those triangles are congruent. Okay. So let's go ahead and move on to example 1. So here's the question. We're given two triangles and we're asked to find out what information or what additional information is needed in order to apply the hypotenuse leg theorem. Okay, so number 1, let's confirm that both of these are right triangles, and we know that they are because of this right triangle symbol, and then this is also a right triangle because of the right triangle symbol. All right, so let's take a look at triangle LMN. We see that this side LN has a length of 9, and what's unique about this side is that because it is opposite the right angle, this is the hypotenuse. Okay, now let's take a look at triangle PQR. We know that the length of QR, which is the leg of this triangle, not the hypotenuse, is 5. Okay, so in order for the hypotenuse leg theorem to apply here, we need to know either the length of hypotenuse PR, so that needs to either be 9, okay, or one of these legs, so let's say leg MN, has to be 5. Okay. So both of those scenarios have to be true. The hypotenuse have to be 9 and the leg has to be 5. Okay, if that takes place, then the hypotenuse leg theorem applies because both of these triangles will then be congruent. Okay, all right, so let's go ahead and move on to example 2. So the question here is, are both of these triangles congruent? Okay, now first, we need to determine if both of those triangles are right triangles. Okay, we see that triangle GHJ is a right triangle because of the right triangle symbol. However, triangle KLM, we don't know if this is a right triangle. Okay, so we need to figure this out first. Well, how do we get this angle? We can get this angle if we know both this angle and this angle here, angle KML. And how would we know that? We should know that the sum of all 3 angles of a right triangle add up to 180. Okay, so if we somehow knew that both the 24 degrees and whatever this degree adds up to 90, then we know that the balance is 90 and therefore it is a right triangle. Okay, well, how do we do that? Well, we see that we have angle 114 degrees for this angle here. Okay, we know also that this angle plus this angle add up to 180 degrees, right? Because it creates a straight line. And we know that a straight line is 180 degrees. So if this were 114, then the balance here would be 64 degrees, right? 180 minus 114 is 64 degrees. So we could say that this is 64 degrees, okay? Now that we know this angle, we can add this angle, and when we do, 24 plus 64 add up to 88, okay? Which does not add up to 90. However, if you were paying careful attention, you'd realize that this angle is not 64 degrees, right? Because 180 minus 114 is actually 66 degrees, okay? So we need to correct this to 66 degrees. All right, now that we have 66 degrees, this changes the scenario. We have 66 degrees plus 24 degrees, which is 90 degrees. So now we know that this is a right angle, okay? All right, so we've established the first criteria, which is both of these triangles have to be right triangles, okay? Now that we have that, we do know that the leg HJ has a length of 5, and the leg LM for this right triangle also has a length of 5, okay? So that's great. However, we still need one more thing to verify, and that is this hypotenuse KM has a length of 13. All we need to know is that the hypotenuse GJ is also 13. And if we can determine that, then we will know with through the hypotenuse leg theorem that both of these triangles are congruent. Okay, so how do we figure that out? Well, you may have learned, and hopefully you've learned, that given two sides of a right triangle, okay, any two sides, you can solve the third by using the Pythagorean theorem. And the Pythagorean theorem states that a squared plus b squared is equal to c squared. Okay, so in a triangle, in a right triangle, that is, A and B are the legs of the triangle, and C is the hypotenuse. Okay, so let's go ahead and plug in these values. We have a leg of 5 and a leg of 12, and it doesn't matter if we substitute A or B for 5 or 12. It doesn't matter. What does matter is that C represents the hypotenuse. Okay, so we go ahead and plug in 5 for A and 12 for B. Okay, that equals C squared. And if we go ahead and solve for C squared, we get 25 plus 144 is equal to C squared. We add 25 and 144, we get 169. That's equal to C squared. Now we're going to square root both sides to solve for C. And we find that that C, or the hypotenuse, is 13. Okay, so now we know GJ is 13. And so now we can confirm that both of these triangles are congruent through the hypotenuse leg theorem, because both the hypotenuse, GJ and KM, are congruent, and one of the legs, HJ and LM, has a length of 5. Okay, all right, so let's go ahead and move on to the next example. And the question here is the following proof correct? Okay, so the proof down here is saying that triangle DEG, so triangle DEG and EFG, so EFG are right triangles. Okay, so that's true. The figure shows DE is congruent to EF, right? DE is congruent to EF, so that is true, and those are the legs. All right, so we're almost there. And we also know that EG is congruent to EG by the reflexive property. EG is equal to EG, so that's true. And now the conclusion is, therefore, by the hypotenuse leg theorem, triangle DEG is congruent to EFG. Okay, now the question is, was that proof correct? Well, it was mostly correct, except for this last statement here, EG congruent to EG. It's not to say that that's not true. EG is congruent to EG. The problem is EG, while EG is the hypotenuse of triangle DEG, EG is not the hypotenuse of triangle EFG. And that's where the error in the proof exists. Okay, so both of these triangles therefore are not congruent. Okay, let's go ahead and move on to the last example. And the question here is, which statement proves that triangles are congruent using the hypotenuse leg theorem? Okay, so let's take a look at both of these triangles. Triangle ABC is a right triangle, so that's good. And triangle DFE is also a right triangle. Okay, so that's good. One of the legs is congruent to the other leg, so we have that. So the only thing that's left for the hypotenuse leg theorem is that we need to have both AC and DE, which are the hypotenuse of both of those triangles. We need those to be congruent. Okay, so let's go ahead and take a look at option A. Option A says angle A and angle D are the same. Well, that doesn't help us, so that can't be it. So let's go ahead and cross that out. Selection B says AB, length AB is congruent to DF, so AB congruent to DF. That doesn't help us out because those are the legs of the triangle, so that's not it. Let's take a look at option C. Option C says angle B and angle F are congruent. Well, that's true, they are congruent, but that's not the additional information that we need. Okay, so that can't be it. So let's take a look at option D. Option D says AC is congruent to DE, and that's exactly the hypotenuses of the triangle, and so therefore option D is our answer. Okay, so hopefully through those 4 examples you have a much better understanding of the hypotenuse leg theorem and how they can be applied. If any of this was confusing, or if you need further clarification, please go back to the beginning of the recording and listen to this again. Thank you.